Crystallization video part 2. Part A. Dissolving and saturating your samples. In this experiment, we will find out that each sample has its own unique properties. We have a choice of 5 different samples: table salt, sugar, Epsom salts, alum, and potassium nitrate, as shown on the screen. To make a saturated solution, once we have chosen our sample, we will need to carry out the experiment 3 times to obtain an average and record our observations. After following this experiment thrice, what we will find in the end is that the sample is not dissolving anymore at the same temperature. While doing this experiment, we will all need to write our observations in the worksheet provided. A saturated solution can be defined as one which will not allow any more of the solute or sample to dissolve at a specific temperature. As we can see on the screen, there is a solute such as salt or sugar or anything that dissolves. Then the solvent, water, oil, or any other liquid substance. A saturated solution can be defined as a solution in which a maximum amount of solute is dissolved at a specific temperature. Materials required for this experiment: clear plastic disposable cups. For example, beakers. The 5 samples, for example, table salt, sugar, alum, potassium nitrate, or Epsom salts. Half a cup of each sample is sufficient. A teaspoon or spatula, cold tap water, a small measure capable of measuring 40 cm³ is required. For example, a measuring cylinder, beaker, or a clean medicine syringe. Balance or kitchen scales, and a thermometer. After buying the materials, the procedure we need to follow is: 1. Accurately measure 40 cm³ of cold tap water into a clear plastic disposable cup and record its mass. Record this in the student worksheet provided A. 2. Carefully add 1/4 of a teaspoon of our sample, table salt, sugar, Epsom salts, alum, or potassium nitrate to the cup of water and stir for 30 seconds. Once dissolved, continue adding 1/4 of a teaspoon measures, followed by stirring until no more of the sample will dissolve. Measure the temperature of this saturated solution and record it in the table B. Record the mass of the cup and the saturated solution, which should have 1/4 of a teaspoon of solid sample sitting at the bottom. Calculate the mass of the sample required to saturate 40 cm³ of your local tap water. This can be recorded in the table D. To ensure that the data acquired is consistent, repeat the steps 1 through 5 twice or more and compare with your groups. Using the student worksheet, Calculate the average temperature of the saturated solution during the experiment. Record in the table E and record this for posting to the website. Calculate the average mass of our sample needed to saturate 40 centimeter cube of our local tap water. Record in the table F and record this for posting to the website. Gather the data for all 5 samples and record these in a tabular format, as you can see on the screen, to reach the overall conclusion.